Today's lesson will be on the transfer of energy. It is our first lesson in our new unit of astronomy. Your objective for today is to be able to give real-life examples of the terms conduction, convection, and radiation by the time the video is over. To start today's video, we have to understand the law of conservation of energy. This law states that energy cannot be created or destroyed. It is only changed from one form to another or transferred from one object to another. So it's incorrect to say that you created energy or that you lost energy. It's really just changing from one type to another. When we transfer energy, energy is always going to move from a high concentrated area to a low concentration area. And it's always trying to establish dynamic equilibrium. So if we take a look at this simple diagram here, you can see that in section A you have the blue dots, and in section B you have the purple dots. Because energy moves from high concentration to low concentration, the blue dots will move to the purple dots in order to try to receive some sort of equilibrium or to make their amounts equal. There are 10 blue dots and 5 purple dots. So in this instance, you can't get an even amount here because the difference is 7.5, but it will still try to move to create that equilibrium. So always whatever you're losing from one side, you will gain on the other. So if we lose one blue, we're going to gain on the purple side. Let's do a practice problem dealing with this. The question says, what will the temperature be when the system below reaches equilibrium? Well, we have this calorimeter A with water at 100 degrees Celsius and calorimeter B with water at 20 degrees Celsius. Remember, energy will move from high concentration to low concentration, so our energy will move from A to B. It's going to move through this metal bar. In fact, I'm sure some of you have already done this experiment before in lab. What we want to do is we can just add up these two values. So 100 plus 20 gives us 120. And then we can divide by 2 because there's 2 calorimeters, giving us a temperature at which we would reach equilibrium, which would be 60 degrees Celsius. What will happen is, remember, your loss will equal your gain. So if you lose 5 degrees over here, this becomes 95. Gain 5 degrees over here, that comes 25. And again, that will happen until you reach equilibrium, but to just do it quickly, we added and divided by 2. There are 3 methods of transfer that we want to talk about today. The first one is called conduction. This is the transfer of energy from atom to atom or molecule to molecule when vibrating atoms or molecules collide. Remember, in simpler terms, we're talking about conduction happens when you are touching other things. So if you look here at this picture, we can see that this guy has this glove on because he's touching a metal rod that seems to be in some sort of fire. And if he touched that, he would feel that heat. That heat would be transferred to his hand. Now, hopefully you know already that conduction is more effective in solids because the atoms and molecules are closer together. And if they're closer together and they're vibrating and colliding and touching one another, that heat is going to be transferred a lot more quickly. So solids, metals, okay, they're going to conduct a lot faster than plastic or wood would. But just in general, conduction is the transfer due to touch. So what does this look like? Well, if you think about your kitchen, if you've ever touched a pot that didn't have like a rubber handle on it, you probably got burned because, again, that's conduction. If you sat down in your seat today and you felt that your seat was either warm or cold, that was the transfer of energy through conduction. So anything you're touching, you can say that energy is transferred through conduction. Convection is the second method of transfer, and this is the transfer of energy caused by difference in density within liquids or gases. We look at this radiator here, and we can see that warm air is going to rise and cold air sinks. Warm water does the same thing. Warm water rises and cold water sinks. And as that process happens, it's creating this current or this convection current. This will happen again until we reach equilibrium, when our loss equals our gain. So your water will not boil in this until you've reached that temperature that's desired. So here you can see there's a radiator in a room. You turn the heat on. What's actually happening? Well, you can't see because it's air, but the warm air rises, the cold air sinks, and the heat will shut off if you have it preset when you reach the desired time or temperature, which is when you reach equilibrium. So in the kitchen, if you've ever preheated your oven, and it beeps at like 350 or whatever time you have it on, that's because convection was taking place. The air within your oven is hot air is going to rise, cold air is going to sink until it all becomes that specific set temperature. Remember, cookies don't bake if you put them on the stovetop, and that's because they're just touching the bottom would burn. Again, that's conduction because they're touching the bottom. The last method, and probably the most important, is radiation. Radiation is traveled via electromagnetic waves, which we're going to discuss a lot tomorrow. Big thing here that you need to remember is that radiation does not need a medium to travel through. So you can see in this picture here, this person is standing next to the fire. They're not touching the fire, but they can still feel the heat from that fire. The higher, obviously, the temperature of the object, the more electromagnetic energy will radiate. But think of an example that this could be. How about the sun? We're going to talk a lot in this unit of astronomy about our sun and what we get from our sun. And it does radiate light, and it radiates that heat to our planet. And then there's just a guy here standing next to a fire, getting warm and roasting his marshmallows. Again, based on radiation. He's not putting them in the fire. He's getting that through no medium. It's just radiating through empty space. So in review here, we're looking at conduction, convection, radiation, convection currents in the pot. Remember, due to differences in density, conduction, she's touching the handle, and then radiation, no medium, she can feel the heat from the fire. So what we'd like you to do is you can end the video here. We're going to talk about this when everyone's done. Try to list as many examples, real-life examples of conduction, convection, and radiation, and try not to use examples already used in the video.